Hello and welcome back. I want to quickly just prove this main lemma about absolute value. So it says that if we want the absolute value of something to be less than c, and c is a positive number, then that's really no different than saying that our number is between c and negative c. And so to prove this, we have to do two cases. We have to do one case where z is positive or equal to 0, and one case when z is negative. And just to remind you, the absolute value of a positive number is just that number itself. The absolute value of a negative number is the opposite of that number. Okay? And so now let's see how these proofs are going to go. And so each of these has two directions. So I need to show that if the absolute value of z is less than c, then the conclusion is going to be true that z has to be between c and minus c. Okay? But, all right, well, that's exactly what we need to show. That's the left-hand side up here and the right-hand side in our statement of our theorem. But in this case, what do we have? Well, we know that the absolute value of z is z, and that z is greater than or equal to 0. And so in this case, the absolute value of z is less than c means that z is less than c. And since z is positive, remember that was our working assumption in case 1, we have actually that z is between 0 and c. So therefore, of course, z has to be between minus c and positive c, right? Because negative c is going to be less than 0. Okay, so that was the forward direction. Now we have to do the backwards direction. So now let's see, need to show that if z is between negative c and c, then the absolute value of z is less than c. Okay. And again, what are our assumptions? Well, we know that if this is true, then, well, certainly that's going to mean that z is less than c, right? Because that's just half of that inequality. But notice that z, this thing I'm circling, is exactly the same as absolute value of, let me just do it this way, which implies that the absolute value of z is less than c, right? And where is this coming from? This is just literally the fact that in case 1, the absolute value of z is the same as z, right? So again, we proved what we needed to show. So if at this point in the video you're feeling like this is pretty boring, feel free to just turn it off, because the second case is pretty much exactly the same. This is one of those facts that feels really true and the proof's not so enlightening. But I'll finish doing it. Case 2. This might be good for practicing how do we prove these double arrows. So what do I need to show? I need to show that if the absolute value of z is smaller than c, then, then that's going to mean z is between negative c and c. So how do I do that? Well, let's see. Well, in this case, so if the absolute value is less than c, then using our fact that the absolute value of z is negative z, so that means negative z is less than c, we rearrange things. That's going to mean that minus c is less than z. I just moved this z to the right-hand side and moved c to the left-hand side using subtraction. So we've got that z is greater than minus c, and so now, therefore, negative c is less than z, which in this case is less than 0. And so therefore we can conclude, just like we did in the first case, that z has to be sandwiched between c and minus c. And now finally, the very last part of the proof, I will maybe do that on the next page. The very last part of the proof is going to be that other direction, that we need to show that if the inequalities are true here, then the absolute value of z is going to be smaller than c. And so again, we'll take that statement: if z is between negative c and c, then of course just half of it's going to be true. Of course z is going to be bigger than minus c, which means therefore that negative z is less than c. That's again moving things around. And of course negative z is the same as the absolute value of z. Let's remember that since z is negative, the absolute value of z is going to be minus z. So that's going to be exactly the same as that statement there, which is what we wanted to prove. So thank you for watching. I don't think this is super important. I think that this is kind of a tedious, maybe boring sort of statement to check. I really promise that in this class it's not going to be proving boring statements. We're actually going to be proving pretty interesting statements, and our proofs are going to be creative, and we'll start doing that already next week once we know what the completeness axiom is. So thank you for watching, and I'll see you soon.